Hello folks, thank you for watching another Murphy video. This time I'm going to cover the first half of section 1.3 in honors geometry, that is essentially working with midpoints. The second half of this deals with distance, the distance formula between 2 points in the coordinate plane, but I want to keep this video short. We'll just talk about the notion of midpoints first. We'll start by talking about what a midpoint even is. It is exactly what it sounds like, basically. This shouldn't be too surprising to people to hear that a midpoint is a point that is halfway between two other points, all collinear with one another, which is to say it's something that's going to divide a segment into half. It's going to divide it into two congruent segments. We talked about congruence in section 1.2. It just means that two things have the same measure. So in this case, if I know that M is the midpoint of segment AB, that indicates that AM is going to be congruent to MB, which is to say that, for example, if this is 5, if AM is 5 units long, and MB therefore is also 5 units long, the whole thing would be 10. Half of 10 is 5, 5 and 5, yada yada. Not a groundbreaking idea, but nonetheless, a vocab term that we're going to have to remember we're going to use quite frequently. So if we were together, this would hopefully generate some conversation about whether or not, here we can see a segment has a midpoint, obviously, but can a line have a midpoint? And the answer, long story short, just so that we get to the important stuff quicker, no, it cannot. And in the past, we've had some conversations about why not? Why isn't 0 the midpoint of a number line, for example? There's all the positives to the right of it. There's all the negatives to the left. There's an equal amount of positives and negatives, so why can't we say 0 cuts the line in half? Well, because it's impossible to say that this ray to the left and this ray to the right are congruent. That would mean they have the same measure, and infinity is not a measure. Both of these are infinite units long. And furthermore, I could show that this is not the case if I wanted to, for example, say why not 1? There's still infinite points to the right of 1 and infinite points to the left of 1, so why isn't 1 the midpoint of a number line? And the logic would be the same, right? That if we did consider it to be a midpoint, then infinity to the left, infinity to the right, then every point on a number line would be a midpoint, and that wouldn't make much sense, would it? So we say that no, line cannot have a midpoint, and for the same reason, neither can a segment. Neither can a ray. The notion of you can't break up infinity into measurable quantities. It's not how it works. There's not much to talk about here, not much to do, rather, when we're talking about segment bisectors. A segment bisector is a figure that intersects a segment at its midpoint and bisects it. So I know you know what intersect means. That just means that they cross paths. There's some sort of, in this case, a point of intersection at M. But to bisect something, if we think about the prefix bi, like bicycle, it's going to cut it into two congruent segments. That just means that it goes through something's midpoint. So here, just to kind of know what we're looking at, what we see is that CD, line CD that is, the green line, is the segment bisector. I'm going to call it SB for short because I'm lazy. It's the segment bisector of AB. That is segment AB. It goes through point M. That's the midpoint. We can see that because of the congruence marks. Boom, bisector. The next thing is something of, I guess, more significance, and it's how do we use the notion of segment bisectors and midpoints to actually solve problems, to create equations, to find unknowns in geometry. In this one here, it's pretty easy. We see line L as the bisector, we're told so. That cuts it in half. That means that the two halves are the same. So their measurements, 5x minus 7, and 11 minus 2x, are equal. From here we can solve for x. I'll add 2x to each side. I will add 7 to each side. I'm hoping that we can handle this Algebra 1 content without having to show too much work. I'm also on a mouse right now that I have hooked up. It's not the cleanest way of writing things, but I hope it's sufficient. That's my excuse for sloppy handwriting. And we end up getting that x equals 18/7. A weird fraction, but hey, sometimes in math we're to get weird fractions. The next part might look basic, but it's going to lead up to a much bigger concept. So tune in for this, the notion that I'm looking for a midpoint on a number line. I'm looking for a point that is halfway between point H and point I on this segment. So yes, you can kind of count inwards one at a time, go 1, 2, 3 this way, 1, 2, 3 this way, and then halfway in between, so I guess it's negative 0.5. That's a fine way. That demonstrates that you know what a midpoint actually is. That's cool. But it would be nice if we had something more sophisticated than just counting inwards, right? That wouldn't work if we had very long segments. So what we should consider is that the halfway point between two endpoints is going to be their average. A midpoint is essentially the average of the endpoints. How do we find the average of two numbers? You add up their coordinates and you divide by 2. So I could say M's single coordinate is going to be negative 4 plus 3 divided by 2, which, as a surprise to absolute no one, is negative 1/2. And there it is, as we predicted. And I'm mentioning this right here, the notion of taking an average of coordinates, not because it's necessary for this problem, but because we should consider it when we're dealing with a line on a coordinate plane. Because now we don't just have x's left and right, we have y's up and down as well. And as it turns out, the midpoint formula on a coordinate plane isn't that much different. Like, if I were to plot point M somewhere, just use your intuition. You know it's going to be somewhere around here. That looks like it'd be about the midpoint of the line, right? Of the line segment, rather. What we could say is that it's going to be about halfway up from A to B and about halfway right from A to B. So if we just break it up into the x and y components, it actually works the same way. I can say that to go from A to B, I'm going up, what is that? From -7 to 5, looks like I'm going up 12. And I'm going right from A to B, let's see, -5 to 3, which is 8. So I'm going up 12 and right 8. What if I went up 6 and right 4 instead? That would be halfway. That's certainly a way to get the midpoint. But if I just note previously what I had done, which is take the average of the coordinates, I can do that again, but twice, basically. Once for the x's and once for the y's. So here's a formula. This is the midpoint formula. We will certainly utilize this in the future. Try not to get stuck in memorizing it, because you're going to get it confused with the slope formula. Once we talk about the distance formula, you might get that confused with it as well, because it both involves x and y subscripts of 1 and 2. You might do like x1 plus y1 or something. It's just very easy to mess this up. Don't think about it in terms of memorizing the formula. Think about it in terms of common sense and logic. How did we get to this conclusion? We took the average of the x's, comma, average of the y's. That's what gets us the number that's in the middle of two other numbers. We take their average. In this case, we do it twice. So, we might as well try to find the midpoint here. We guessed it would be somewhere around here. Distance formula is going to be safe for part 2 of this. When I say find both, I'm really trying to find the midpoint. According to the formula, according to me taking the average of the x's and the y's, the average of the x's, let's see, would be -5 plus 3 over 2. And the average of the y's would be -7 plus 5 over 2. So -5 plus 3 is -2 over 2. And -7 plus 5 is also -2 over 2. Which means the midpoint is therefore -1, comma, -1. Something to consider is that the midpoint is a point. So if we're on the coordinate plane, it's going to have an x and y coordinate. There's going to be 2 parts to it. And then also something to consider is after we get our answer, we should check back to the diagram and see if it makes sense. -1, -1 is right here. And it should look about halfway between A and B. It's a good sign that it does. And of course it is, because we did it right. Because it's my job to do it right. So this isn't actually present in your notes or the note key. What I did is I just kind of took a random problem from Khan Academy and threw it on here so that I could do it for practice for you folks. I'm just going to roll through this. It would be wise of you to maybe pause this and consider doing it yourself on a loose piece of paper, something you have on the side, just to see that you can do it on your own. Because remember, watching me do it and you doing it from start to finish on your own is a totally different thing. Just because you understand it when I do it doesn't mean that you understand it well enough to handle it on your own. So my advice, pause it and try it. But anyway, here I go. This is a very straightforward problem. Point A is that, point B is that. We want to find the midpoint. We have the endpoints of a segment. We're looking for the midpoint. Intuition says it's going to be somewhere around here, just because I can kind of gauge where the halfway point would be if I eyeball it. But eyeballing it ain't how we do stuff in here. We have a more precise method than that. Let's take the midpoint formula, which is, again, average of the x's, comma, average of the y's. Average of the x's is going to be -6 plus 3 over 2. Average of the y's is going to be 5 plus -7, which I'll just write as 5 minus 7 over 2. And this simplifies to -3 halves, which we can leave like that if we want, and -2 over 2. Just to kind of visualize this better, I'll convert this to a decimal. That's -1.5, comma, -1. Just to check, first of all, -1.5, -1 is on a line. It is on the line, I should say, which is fantastic. That's a good start. And it does look like it's about halfway. So that's a good way of checking our answers. We want to make sure that after we actually do the calculations, that the result that we get seems sensible, and it does. One more problem, and even though it might look like the previous one for starters, it's actually a little bit more complicated. So don't skip through this. In fact, I recommend you pausing it and trying it as well. Let me also change color. If you're pausing it soon, pause it now, because magenta's not good. I'm about to get going, so unpause when you're ready to go. This one's different because we're not given an endpoint and a second endpoint and asked for the midpoint. We're given one endpoint and the midpoint and asked for the other endpoint. So before we were given A, B, and told to find M. Here we're given AM and told to find B. So again, if we kind of eyeball it, if we imagine how congruence and midpoints and collinearity works, we would expect B to be somewhere up here. I'm not going to eyeball it, though. I'm going to actually kind of try to do some work here. There's different ways that people can do this. I recommend... I have a pretty foolproof method for this one, I think. And it comes with, obviously, identifying what the coordinates of the endpoint and the midpoint are. This appears to be 2.5, comma, negative 1.5. Great. And this kind of relies on what more or less feels like the slope formula, which is that to go from A to M, I'm going to go right some, and I'm going to go up some. And what we should note is that to then go from M to B, I'm going to go up and right the same amount. So what we should be doing is saying that from A to M, that's from negative 7 to negative 1.5. That is a difference of 5.5. I'm increasing by 5.5. And to go right, I'm going, let's see, that's from negative 2 to positive 2.5. That's an increase of 4.5. So if I were to go up 5.5 and right 4.5 again, that should put me at point B, because I would expect this up and right ratio from A to M to be the same. That's what it means when M is in the middle. Alternatively, I could just go up and right double these numbers. I can go up 11, right 9 from A, but instead I think I'll just go up 5.5 and 4.5 right from M instead. So from this point M, if I go up 5.5, let's see, this might be hard for my brain actually. That's negative 1.5 plus 5.5 puts me at 4. Great. And then if I go, that was up 5.5. If I go right from here 4.5 units, so that's from positive 2.5, 4.5 units right, puts me at 7. So it sure does look like point B is at 7, 4. There's a way to do this without even the visual. I'm hoping that made sense to people. And if I were to actually like connect the dots here, it should look like MB. This is gonna be sloppy in advance. I'm warning you right now. It should look like MB and MA are roughly the same. These should be congruent to each other. So what I would want to do is I'd probably kind of want to try to line these up and say A is negative 2, negative 7, and M is what I say M was 2.5, comma negative 1.5. Sorry again for the sloppy handwriting. It's becoming very apparent that a mouse is not the easiest way to do this. Let's say B is green, because why not? So to find green, again, we know what we're doing. We're essentially going up and right the same amount. So let's do this in so many colors. Magenta now. To go from this X to this one, to go from A to M, I'm increasing by 4.5. So if I increase by 4.5 from M to B once more, well, 2.5 plus 4.5 puts me at 7. If I do the same thing with the Y's, to go from negative 7 to negative 1.5, I'm increasing my Y coordinate. I am going up by, brain fart, 5.5 units. If I then do that again, because I know M is the halfway point, if I increase 5.5 units, ignore that decimal. If I increase 5.5 units from negative 1.5, I end up getting 4. So we end up getting 7, 4. Perfect. I don't know why it's not writing down here. I don't know what's going on. But we did everything we need. That's perfect. These are the skills that would be required of you in the future. Remember, this type of problem and the one from the previous page are both, you're now held accountable for this sort of knowledge. Also remember, this is not just a matter of like, geometry is not, you remember the formula, you plug stuff in, and then you're good to know. You're good to go. What you should be doing is kind of trying to understand the concepts. That way, if I were to hit you with a problem that you've never seen before, maybe like this in the previous one, you still have the skill set to handle it. You just have to think a bit. And the best way to handle that is by becoming familiar with the content, whether that's the textbook problems or Khan Academy problems like this, or just talking to your friendly pal Murphy, who can help you through things if you're not understanding things too well. But I think this video is getting long enough. I want to thank you for watching it, and wish you luck in the future. Thanks a lot.